Graph the equations. Solve the equations simultaneously to find the coordinates of any intersection points of their graphs. If the graphs are tangent or fail to intersect, say so. Okay, so what we're dealing with here is we've got with a system of equations, we either have a line and a circle, and what we're trying to do is see where they would intersect. Keep in mind, if a line intersects a circle at two locations, we call that a secant line. If a line and a circle intersect such that the line just grazes the circle or just touches it, intersects it at one location, we call this a tangent line. So in the directions, when it says if the graph is tangent, make sure you say so. Okay. Keep in mind you also have a third possibility that maybe the line doesn't even intersect the circle at all. When it comes to solving systems of equations as well, keep in mind that we have three ways that we can solve. We can solve by graphing, which we are doing because we're graphing the equations. We can solve by elimination to get a more exact answer, or we can also solve by substitution. Depending on the situation that arises, you may prefer one method over the other. Okay, so we have three examples here. Let's just go ahead and take a look at the third example, and I'll let you do the other two on your own. So in this case here, we do see that our equations are giving us two circles. So maybe the circles intersect at two locations, something like this. You have the possibility that they intersect together at one location, so something like that. Or maybe they don't intersect at all, and so you have something like that. Okay, so consider all those options as you are solving this problem here. Now, as I see how I want to solve this problem algebraically, I don't think substitution really makes a whole lot of sense right now, right? Because I see an x squared and y squared, but the other one doesn't quite have that x squared or y squared. So instead, I'm going to use elimination. To do elimination, I'm going to multiply everything through. We'll get x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 13. We're going to combine that with our second equation, x squared and y squared equals 20. I'm going to subtract both of those equations from each other. So the x squareds will cancel out. We'll be left with negative 4x plus 4 plus 2y plus 1 equals, now don't forget this is technically a negative 20, so we'll get negative 7 there. Combine like terms, so we get negative 4x plus 2y, 4 and 1 will give us 5, but then you're going to bring the 5 over to the other side, you'll subtract, and therefore you'll get negative 12. Solving for y, isolating y, we'll get a y value of 2x minus 6. We're going to take that y value, and because now y is isolated, you can now plug it in to any one of these two equations. Hopefully, what you're saying is the first equation makes a whole lot more sense. It's a lot simpler to solve. So let's go ahead and plug that in. We're going to get x squared plus, remember y is technically the same as 2x minus 6. So we have 2x minus 6 being squared, and then that's equal to 20. So we'll get x squared plus 4x squared minus 12x minus 24x plus 36 equals 20. I don't know why I decided to scrunch it all in this little space here. And then let's keep on going. So x squared and x squared will give us 5x squared minus 24x. And then let's bring the 20 over to the other side. So we'll have plus 16 equals 0. So there's our quadratic that we can solve. I don't really know if this is factorable. I'm not going to bother with that. So instead, let's just use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's find that. There we go. All right. So what do we got here? 24 plus, oops, go away, plus the square root of negative 24 squared. Technically, negative 24 is the same as positive 24 squared, so I'll just put it in anyway. Minus 4 times 5 times 16. And then all that is divided by 5 times 2, or 10. There we go. We get a value of 4. Now let's do the negative. So 24 minus will give us 0.8, or that's the same as 4/5. Okay, so we have two x values. Keep in mind what this means is on your diagram, even though you might have two x values, we still need to find them as ordered pairs, so we gotta find the y value now. So with that x value in play, let's go ahead and solve for y. Think about which equation makes a whole lot more sense to solve for y. I would want to do the first equation. That seems to be a lot easier, right? So x squared plus y squared equals 20. And if I'm trying to solve for y, then that must mean that I'm going to get two answers because I will have to square root it. And remember, when you square root your equation, you need a plus minus. So keep that in mind, okay? All right, so if I plug in a 4 here, then that must mean 4 squared will give us 16. 20 minus 16 will be 4. So we're seeing here that when x equals 4, that y is equal to plus minus square root of 4 or 2. So we have the possibility of 4, 2, and we also have the possibility of 4, negative 2. Okay, then let's also do our other case. Let's do 4/5. So if we plug in 4/5, y is equal to plus minus, do I have room here? No, I don't have a whole lot of room. So square root of 20 minus 4/5 squared. 4/5 squared, that would be the same as 16 over 25. And if I get that to have common denominators, 25 and 2 is 500. So we're going to do that. And 500 minus 16, that'll give us 484 over 25. So we're finding the square root of 484 over 25. I believe that is 22 over 5, plus and minus. Okay, so we also had the values of 4/5, 22 over 5, and 4/5, negative 22 over 5. So we have these four possibilities. Now, also recall that because we had square rooted and we got plus minus, it is very important that you check your answers. As you can see in our diagram, a circle may intersect twice. I don't know. It's never going to intersect 4 times. So we're getting too many answers. We're getting extraneous solutions here. So let's go ahead and find which values don't make a whole lot of sense. Okay. Let's go ahead and try this one first. 4, negative 2. So if we plug in 4, negative 2, I'm just going to go ahead and raise a little bit of work here so that way you can see my checking. Okay, so 4, negative 2, if we plug that in, 4 minus 2 will be 2, squared is 4, and negative 2 plus 1, that'll give us negative 1 squared, that's 1, and 4 plus 1, no, that doesn't equal 13. That's showing us that this is not going to be an answer here. Okay, let's try it again. This time let's try this one here. Okay, 4/5 and 22 over 5. So if we do 4/5 minus 2 squared and 22 over 5 plus 1 squared, let's see if we get a value of 13. And I'm just going to use my calculator here. Clear all. So, oops, I should probably do this in split screen view so I can see. Open in split screen. All right, so we have 4/5. We're going to take that and minus 2 and square it. And then we're going to add that to 22 over 5. And then we're going to add 1. Oops. Add 1 and square it. Oh, we get 30.6. That is definitely not 13. So because it's not 13, that's not our answer either. Okay. You can double check your work. Of course, this in the interest of time, just for our sake, I'm not solving for 4 over 2 or 4/5 negative 22 over 5. You can do that, but what you'll see is that these will be your solutions. Okay. Let's double check that. So we're going to have to now graph it. You know, the problem did tell us to graph it. So let's go ahead and I'll do this in red actually and graph these. Okay, so for our first equation, we see that if we want to find the radius, that's the square root of 20. The square root of 20 is roughly around 4.4, maybe 4.5, somewhere around there. Okay, so let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what I'm just showing you here, the reason why I'm hand drawing this is really kind of showing you, remember all your characteristics of drawing circles. You want to always think about the radius going outwards in all directions for that same amount. Okay? And then when it comes to something with a transformation, you apply the transformation by, in this case, shifting right by 2, and then shifting down by 1, putting your center there. And then understanding that since we are looking for the radius, we're looking for square root of 13. That is probably around 3.6, maybe 3.7, somewhere around there. So let's go ahead and plot from there. We're going up 1, 2, 3.6 or so, and then over 1, 2, 3.6 or so. 1, 2, 3.6 or so down here, and 1, 2, 3.6 right around there. So once you connect those, make your circle, something like that. Something like that. You can see here that you now have 2 intersection points, one here, and that looks pretty accurate. That looks like right around that 4, 2 that we had said in our answer here. And then lastly, the other one here would be the 4/5, comma, negative 22 over 5, and maybe that one is not quite so accurate, but let me just bring you over to a more accurate circle. Here's Desmos. You can see here our answers are 4, 2, and 4/5 and negative 4.4. Yeah, and that'll be it.